All right, so the next one we're doing dial-up internet access. So this figure shows actual and predicted figures for the percentage of residential internet access that is through narrowband dial-up access only. We're supposed to describe the behavior suggested by the scatter plot, and that indicates a logistic model might be appropriate for the data. Well, if we're looking at that one, it looks like it starts out concave down. There's at some point it switches to concave up. So I think that inflection point where it switches is going to be our key item here that we can say that is what's going to do it. Then B says the table reports the data illustrated in the figure and find a logistic model to fit the data. Okay, so I'm going to plug that in, and then we're going to write the equations for the two horizontal asymptotes. All right, so what we need to do is go to our calculator, and we need to enter the data. And I aligned it so, the 2000 was times 0, and then I went all the way down to, 2014 was going to be 14 years, and then all the corresponding narrow band percentages. All right, so what do we do now? Well, now we're going to go, we can see what our graph looks like. Looks pretty much like the one they gave us in the book. But now let's actually do our logistics plot. Now, one thing about these, they take a long time sometimes to work. So logistic is, well, here you're going to arrow up, and then we want the B. So we have to arrow up to B. We hit enter. Make sure you have L1 and L2 in the right spot. And then again, we're going to do our vars. Go over to Y variable, and then we'll do one for function, one for Y1, and enter and calculate. And notice it's spinning and spinning. It takes a while because you're trying to calculate this formula that's a little more complex than just a simple linear equation or even an exponential or anything like that. And so some of them, when it's working, it'll take 20, 30 seconds minimum on some of these harder ones. So don't worry, it's doing something if you see that circle going. All right, so this is what we get for our function. And again, if we look over here, this is what it looks like. You have the 103.880 on top, and then over 1 plus the 0.167 times E. Now notice here they have minus a minus 0.509 times our X. Now a minus means plus, so this is just a plus value here. So that's just because that's how, when you do the plot, it's e to the minus b, and b is a negative, so they just show you that that's what happens here. Now let's look at our graph. Okay, so that's what it looks like. That looks good. And so what we've done is we've now found a logistic model, and so we need to write that down. And then we need to write the equations for the two horizontal asymptotes. So once we write down our equation here, then we can write the asymptotes pretty much directly from that. So part A, that was the change in concavity indicated logistic. Okay. Now B we had then was let's call it f of x, I guess. It's actually RT, but that's okay. We'll do f of x, and I can use x's instead. And so that was if I have that was 103.880 over 1 plus 0.167 e to the, now remember, a z to the negative negative, which is positive 0.510x. Okay, and so that was our function we came out with logistically. And then C, two horizontal asymptotes. Well, one's going to be this one, and the other is y equals our 0. And again, this is approximate because we have rounding errors and stuff like that. But that would be how I would do this problem. And again, the whole key was putting in your data, aligning. So these are, 0 through 14. And that's usually the most common thing to do whenever you see years, is to put 0 as the first one, unless they say, instead align 0 equals 1995 or something like that, and then you have to go up to 5, and then 6, 7, 8, 9, and so on. Okay. All right, so we'll stop there and we'll come back with another one.